I've also just realised I came and accidentally dressed into the colours because I didn't realise that Primark sell pills and t-shirts. Okay, so second time of the evening, we'll introduce Ryan and Mauricio, who we had a curfew of 9 PM, so apologies for them to go slightly faster than anticipated. They're from either Activiti or Alfresco, which I'm sure is a distinction they'll explain to you. I'm going to talk to you about Monolith, Kubernetes, so give them a hand, please. Thank you very much.
Thank you guys for staying. We know that it's late. We have a bunch of stuff to throw at you guys, so let's start with a round of questions. How many of you guys are looking into Kubernetes? Yes, exactly. Yeah. How many guys are like Java developers? Okay, that's good. Yeah, don't judge that. We are Java developers, but we are here to share a little bit about our journey using Jenkins-X, and we will explain a little bit about what Jenkins-X is. How many of you guys know Jenkins-X? I guess that the Kubernetes people is looking at it, right? Like that's why we're using it. So we work for this project that's called Activiti, and we started with a monolith, with a very big web application, and we are starting to migrate that into microservices. Yes. Okay. So we faced kind of like a lot of issues. We had tons of different services. We are a very small team, and we need to do a lot of stuff here. And our main target was Kubernetes. Right? We were not planning to deploy this thing anywhere else besides Kubernetes. We made that decision a year and a half ago, and we found out that the only way to get that done with a small team is to have CI/CD from day one. Right? Without that, it becomes really, really complicated. So we started looking around about what were the options at that point, like a year and a half ago, and we saw this project Jenkins-X starting. So we joined them and we started collaborating with them in order to be able to, accomplish our mission, which was quite complicated.
What we're going to do in this presentation is take you through that journey and how we started with that monolith, how we we started moving to microservices, and found we had lots of different types of artifacts, and we needed to get these running correctly together in Kubernetes and know when something goes to something else. And how Jenkins-X helped us with that, how Jenkins-X gave us answers to a lot of our questions, and taught us how to practice continuous delivery and do it in a way that works really well with Kubernetes.
Yeah, and it is important to mention that this is an open source project, and we are doing the CI/CD also. Everything is open, so you can check our pipelines, you can check our clusters that are running the pipelines. And because now we switched from being a Java project to a set of microservices, we realized that the first thing that we see in there is that now we expanded our service, basically. So now we are releasing Java artifacts into Maven Central, and now we have Docker containers, and now we also are using Helm to distribute our charts, which are our deployments. So we started with Monolith inside Bamboo, we were using Bamboo, and we started to figure out that if we want to do CI/CD with this setup, we will just need to go and create all of our pipelines, configure all the services, and that was kind of like a lot of work that a team of 3-4 developers definitely cannot do.
Yeah, so this slide here should help to illustrate where we were to begin with. We had one project, one pipeline, one type of artifact. Essentially, we were building maven artifacts we were releasing to Nexus. And normally it was triggered manually as well. So when moving to microservices, we changed the type.
And also we start realizing that again, because we have more artifacts, different pieces, and our customers or the people that is looking into our framework, they will build their own things. And because we were targeting Kubernetes, we realized that we are not in a Java environment. Now we are in a Kubernetes environment, everything is polyglot, there are tons of tools available, there are different cloud providers, so we need to take all this into consideration while we are building on top.
Yeah, so this universe of different tools and artifacts presented a lot of questions, like which ones do we pick, which flavors, where are they hosted, how do we run them?
Too many questions, too many open questions, and not really a very good set of good practices around that. The previous presentation was great because it was giving you some best practices about how to build pipelines. This takes things to the whole new level, I would say. So that's basically what Jenkins-X is. When the first misconception, and this might be a little bit controversial, is that Jenkins-X is not Jenkins. So you need to kind of like see that Jenkins-X is way much more than Jenkins, and it's basically a set of things installed that we use Jenkins for the pipeline control, right? But it's not Jenkins.
Yeah, so maybe actually we can see a little bit about that, because there's with Jenkins you get a Jenkins-X, you get the JX CLI, and one of the things that will do, one of the things it expects you to do is to create a cluster. So you use the when you use the CLI, you create the cluster, JX create a cluster, and out of the box, it will make decisions for you about what tools are going to be installed in this cluster. So Jenkins is going to be installed in there, but you get a whole lot of other stuff as well. So it's going to make those decisions that we were talking about where my Docker contains, or Docker images can be, where my helm charts.
In general, Jenkins-X provides you the environment in order to build microservices. So it's a very opinionated platform looking at Kubernetes. So it was designed inside Kubernetes to work in Kubernetes and to be able to deploy things into Kubernetes. The video that is running here is basically showing how to create a Kubernetes cluster, how to import the Java application, how to deploy the Java application without us even defining what the pipeline is or anything besides the application itself. So you already have an application in any language, in any build tool, you can just import that into Jenkins-X, and it will automatically create a pipeline, fill the project, deploy into the different repositories, and then deploy that into Kubernetes itself.
Yeah. So you won't go far wrong if you think about Jenkins-X as opinionated Jenkins for Kubernetes.
And built for Kubernetes. It's not for everything else. You cannot do all the other stuff that you can do with most CI/CD tools. This is just built for that. So if you're looking into Kubernetes, this definitely makes a lot of sense because they are picking up all the best practices from the Kubernetes community and adding CI/CD on top of that. Architecturally speaking, they have these components in general. When you go to their documentation, you will see this thing, but at the same time, even if you see this diagram, you don't really understand what's going on behind the hood until you use it, right? What we can see here is that Jenkins-X is basically a set of things where you can see the Kubernetes APIs there. You have webhooks, so you can look into Git repositories and include the best practices that were described before, like look into these repositories every time that something changes. The pipelines will be automatically triggered. You don't need to define that. That's basically the default behavior. And then you can see that there is several registries. So you have, for example, Nexus, if you are building Java artifacts to deploy and to release there. And you also have the Docker registry in order to have the Docker images in there. I don't know where the video.
Oh,
sorry, Nexus is there. Yes. Yeah.
Might as well have a look at Nexus.
Yeah, definitely. So you have Nexus installed there, and then you have something that is called chart museum to store your deployment scripts. So by default, you have every time that you import the project here, you create a pipeline that is going to do a Java release into Nexus, into its Java application. Then it's going to do a release into a Docker registry for the Docker image for that application. And then it's going to automatically create a template for deploying that Docker image into Kubernetes. It will create a package for those scripts and host it into a chart repository. So you will get that out of the box without doing much. And plus, you get GitOps on top of that, right? So imagine that you will have different environments, and those environments are going to be hosted into a Git repository and mirror into one namespace inside Kubernetes. So you can have this very nice and interesting practice of making sure that your environment is configured with a source control repository, and you can keep that in sync. Yes.
So we'll explain how this GitOps and CI system, or the continuous delivery setup works as we go along. This will become clearer. So I guess analogous to the JX create cluster, you've also got other JX commands that help to automate some of these the processes. So JX import is another key one, and JX import is a command you can run against a Git repo, and then what Jenkins will do, or the JX CLI will do, is essentially look at your source code and say, okay, have you got a Docker file? And if you don't, then it will add a Docker file for you. It will say, have you got a Jenkins file? And it will create a Jenkins file, a default Jenkins file that's intended to give you that pipeline, a default pipeline that is essentially a Jenkins-X sort of native pipeline. It's the default behavior. And it will also apply give you a default helm chart. That's for deployment to Kubernetes. So Helm being one of the standard deployment tools for Kubernetes for making it a bit easier to produce the YAML files and manage them.
How many of you guys know Helm? Okay, so if you're in the Kubernetes community, you can know it, right? Yeah.
And now just to the JX import, there's also JX create. Have a look at. A little demo of this. And the idea with JX create is, it's essentially the same as JX import, but what you're importing is a template project that is used to just generate you a bootstrap kind of starter project. So in this case, we're watching a video of doing a JX create Spring Boot project. So you see JX create Spring Boot, and it will create you a Git repo for.
So basically what's going on here is just downloading a template, creating a project with nothing in there, like just a Spring Boot application. And as soon as it creates the project, it creates that source controlling into a Git repository, and then it creates the pipeline inside Jenkins to automatically trigger the build for that project, right? So you already get the pipeline, and you get already the project in GitHub in this case, and if you're using GitHub as a provider, you can change that. And it automatically adds into that project the Docker file, the pipeline to build that, and the Helm charts in order to be able to remix that.
Okay, so here we can see what a representation of what happens when that pipeline runs. So we've got this default Jenkins file that Jenkins-X has added for us from the draft pack. What it's also done is it's registered webhooks against the Git repo. So any changes that get pushed to that Git repo, they're going to result in the pipeline running. The pipeline is dictated by what's in the Jenkins file, which we can change if we want to, but we've got a default one out of the box. And what that Jenkins file will do is it's going to build, in this case, a maven artifact, push that to Nexus, and then on top of that, build a Docker image, including that maven jar, and the Docker image will be put into a Helm chart. All of those things will be versioned. So in each case, it's created a tag for this particular commit, and it's going to use that version for each of the artifacts that it's put together.
So going back to that, to the best practices, in this case, for every commit that we merge into the master branch, we will generate a new tag and a new release for these artifacts. So you will be able to go to Nexus and see a new version of the jar file, go to Docker registry and see a new version for the Docker image, and you can go to chart and soon to see a new version for the Helm chart. When we have all this as a release, and of course you will see the tag inside the Git repository, you can start using the Jenkins-X provisioning side in order to put that into an environment. So the pipeline itself will take that thing that was released, add it to the staging environment by default, and then you can work with promotion.
So this idea of an environment is really important to the way that Jenkins-X works. So it's part of the promotion idea. An environment is, in Kubernetes terms, a namespace. So we've got this isolated part of the cluster which is reserved for the running applications. So you get out of the box staging environment, you get a production environment.
You can add your environments, and the good thing about doing this is, again, following the best practice here, like using Kubernetes to deploy the services in the same way that you are going to do it in production.
The environment itself, the state of the environment is represented by a Git repository. So the Git repository contains the Helm chart, and the Helm chart has a requirements file which lists out all the versions, all the microservices that you've deployed and that have been promoted into that environment. So if I go into that Git repository and I'm looking at the requirements file, you can see exactly which fixed versions of all of the microservices have been deployed and promoted there.
Yeah, and then you can kill your cluster, delete the cluster, and recreate your cluster based on those configurations. So you can quickly create and recreate environments, completely entire environments in 5 minutes. Because we have that representation stored in Git, we can recreate multiple clusters.
So this idea of using a Git repo as a source of truth for the environment or the namespace This is very much a GitOps practice. It's very similar to what you find with the Weaveworks Flux tool, but it's more of a principle that you can do in different setups. And the Jenkins-X world, this is the helm chart that you can put.
Another important concept in there is that in order to put something into an environment, you need to send a pull request to that environment. So each environment will have its own pipeline to monitor all the changes that are coming in. So the pipeline basically will see, okay, will say something like, okay, there is a new service, I will send a pull request to the environment to accept this service. The pull request will be built by the pipeline itself. It will check that that can be merged, and as soon as that's green, it will merge into the environment. At that point, the service will pop up into the environment, and you will have the service running.
I suppose another kind of GitOps practice is the Jenkins files themselves. So so this whole idea about I guess one of the other key practices and principles of Jenkins-X is continuous delivery. So tries to push us in the direction of making it as straightforward as possible to automatically run checks and promote things. So the idea is to be promoting as much as possible, making it as automated as possible. So this is one of the reasons why every commit you make into one of the microservice repositories, it gets automatically tagged. It's automatically tagged and versioned, and you get artifacts built so that it's potentially releasable. So that commit has resulted in an artifact that you can then promote and can go into production.
You can imagine now that when we run our pipelines, if we change any of our libraries or services, it's going to create a release that somebody else can consume. That put us in a very, very good position because we have tons of different services, and we can provide to our consumers a way to keep upgrading their environments with the latest versions if they want to. But push it before we even have it.
So here's a representation of of how that flow looks. So we've been talking about kind of a default workflow for Jenkins-X. So here we can see two different types of microservices. We've got a Java one, we've got a Node.js one. Let's say a developer creates a pull request and they want to push to one of these microservices. Well, there's different ways we could then evaluate that pull request, but we'll come back to that. But let's say that somebody decides to merge it, so it gets manually merged into one of these repositories. Well, then the commit is going to get go into the master branch of that microservice. The webhook means the pipeline is going to run. The pipeline is going to generate big versions, build the artifacts, for promotion of that then to the staging environment, we get a pull request generated. So the Jenkins-X Jenkins file that's what it's given us. The Jenkins file means we will get a pull request generated, and that pull request contains something to bump the version of that microservice in that requirements file, which I will probably see it. So in the bottom right there, that's
so just to clarify, the pull request is basically saying, I have a new version for my microservice, just please bump up the version into the staging environment, right? So there is a new version, so that's basically taking into the project and then go to the environment, right? The staging environment is soon. So the pull request was created there. The pull request will be executed by the pipeline, so the pipeline will check if this pull request can be merged. In this case, just bumping up the version, or in this case, adding this new service into the environment. Right? So the pull request will be verified and then automatically merged into master if everything is okay, which will basically cause Jenkins-X to promote that service into the staging namespace.
Yeah. So we touched on the last slides about the how do you get the changes into the microservice in the first place. So let's say we've got a pull request into one of the microservices we code. How do I evaluate that? Or is there any support for that? So beyond what you can normally do by just running unit tests and whatever tests you've got embedded in the pipeline, there is a Jenkins-X idea of a preview environment. which is where it will create a namespace dedicated just to that particular pull request, and it will deploy that version of the app, that microservice, the version that has the code in the pull request. It will deploy that into just that namespace. So you could run tests against that. You can also run tests testing that version of the microservice against the staging environment if you want to. But to make it talk to the staging environment, there's a bit more that has to be done there. That's not exactly just how it's
Yeah, so in general, like, we found it very, very useful because we were looking into Kubernetes, and again, when we look at Kubernetes, it's very unopinionated. You can do whatever you want in there. So having a set of best practices in order how to do CI/CD on top of it, it's very useful. We also saved a lot of time by having CI/CD in place from day one to be able to make sure that each microservice is clearly tagged and released and deployed. We moved from manual releases to automatic releases, every commit, everywhere in our space. And the main reason of this presentation was to share a little bit about our journey, not only Jenkins-X, but what we needed to do in Jenkins-X to make it work for our project.
Yeah, so we are a vendor building open source libraries and components, and as such, we've got particular needs. So we need stuff to be really public. And so that means certain decisions, like using, we really want to use GitHub for our hosting the Helm charts, because they're just easier to see. We don't just mean the source code of the Helm chart, we also mean the artifacts. Because the Jenkins default is to use a chart routine that comes with it sets up in the cluster. So that makes a lot of sense for a lot of projects, but for us, we want to use GitHub. We also want to use public Docker Hub, because that's where you expect open source Docker to be. We already had a Nexus, so we want to use that. And yeah, we also had particular requirements around testing the code.
So our project looks it's quite complex in general. So again, we went from a mono repository that contained all the source code with just a single web application to a set of repositories that contains libraries, like Java libraries, and a set of microservices that are built based on these libraries. Right? So we have the first layer on top, which are the Java artifacts that need to be released. All of these artifacts, not every time that we release one artifact goes to Maven Central, but once a month we are trying to publish these artifacts to Maven Central. That's another important part of this. And then the services, the second layer there, they are all going to Docker Hub, and they are built using these libraries. So every time that the library changes, we need to propagate and build the corresponding service that needs to be bumped up in version. The same with the Helm charts. So as soon as we have the Docker images, we need to jump into upgrading the Helm charts for deploying these Docker images into Kubernetes. So we have this structure. Every time that we make a change, there are tons of pipelines running in order to generate all these artifacts and in order to keep all the releases in sync.
That means changes the pipeline.
Yes.
Yeah, so that meant we needed to be able to change what the result of one pipeline onto the next pipeline, and then actually there's several layers in practice where we need to be able to do that. So it's not just being able to create pull requests into an environment to change the requirements file on the Helm chart. We need to be able to create pull requests into give reposts that contain maven artifacts. You can change the POM file. We need to be able to change multiple different kinds of things and in different repositories. Fortunately, Jenkins-X has a tool for this. It's called UpdateBot. And it can handle lots of different types of artifacts. It knows how to interpret the files to describe them. So it knows how to look for a version inside a Docker file, knows how to look for a version inside a package.json file or a pom.xml as well as a Helm chart. And it's got some other ways of working, so you can search for regexes in text file. This allows us to specify that a particular project is going to push the results of the pipeline to downstream projects. So we create a list of downstream projects and say push to those, and we say this is the type of artifact that we're pushing, and it will then scan the downstream repo as part of the pipeline and say this is the artifact I'm pushing, what version's there, and then it'll reconcile and say, okay, this is the version that should be there, and correct pull request.
one interesting bit about that is that, of course, that the update bot project is, it's an open source project as well. But because we have this kind of like large Java project with 40 plus repositories and building all these Docker images and all these Helm charts, we are really testing this in like in a real life situation. So we started contributing to this project because this was not supporting all the normal things that you might need like in a real scenario, right? So we get like really deep into that, and it wasn't that difficult to get it working for all these things that we are doing.
Yeah, so actually I think we can see a little demo of this. Yeah, so let's just jump into this a bit further in there. Okay, so that's the update block command. So that's being run as part of the Jenkins file. I jumped a little bit. And what it's doing there is the update box now cloning all of these the target repos. Yeah, we can see cloning. So we've got the list of target repos it's cloning more. This particular repo that it's running on has got a lot of target repos, so downstream repos that it needs to push through to. And some of those repos, we have their pipelines in other windows there. So we'll be able to see the result of pushing into them. So here now the update box just logs that it's created a pull request into one of those downstream repos, and we click into that and get to see the pull request. The pull request was generated by a bot user that we have that runs the pipeline. So these pull requests, they don't get created by like the developer, they get created as under the user of the running pipeline. We can see that user, the number of pull requests in the bottom left, that just like the load just appeared, and that's because it's creating all these pull requests. And each pull request is getting evaluated in the Jenkins. So we're seeing these pipeline jobs start appearing, and that's because each pull request needs to be evaluated. Those PRs are being, those branches are being scanned as part of its pipeline setup. So all those jobs running.
So as I mentioned before, we had 40 plus repositories. We didn't create a single pipeline for it, right? Like all the pipelines were automatically generated. That's the default behavior from Jenkins. But we did some tuning, for example, like merge automation.
Yeah. So as I say, the pull requests that are created by the update bot, you need to decide how you're going to manage those. You don't want to go clicking through all these pull requests and merging them and decide whether they're good or not. What you need is automation around this. So it's important that you be able to run good tests in each of those pipelines. But you can also, what Mergify really help us out, is Mergify allows us to set up rules, so we can say, okay, so if the developer's putting a pull request into this repo, it needs a manual, it needs someone to approve it, it needs another developer to approve it. But if update bots push into this repo, then it's fine as long as the tests pass, then merge it. So that enables then to the next stage of the pipeline to run. Because then it goes into master branch has its own update bot command, and you get these changed pipelines that will just go through automatically. So an important part of that then is having good end-to-end tests. Because this whole setup now that it's going to be increasingly automated, but to be able to rely on that, you need good tests, you need trust. So we've got like a number of different types of tests, but the end-to-end ones are the most important because they test the deepest and they test the running microservices against each other. And the way we've set that up is to have a number of different repos that represent different scenarios or example use cases. Each one has a Helm chart. The Helm chart has a set of components that represent a particular way of using our stuff. And we deploy into that. We do all that Helm chart gets deployed automatically as part of that pipeline, and we run a set of end-to-end tests, which are these like PPD style tests, which call the whole load of endpoints, do the stuff to make sure that these work together.
It was really, really important for us to understand that because now we are working with a distributed system, we need to make sure that our test goes to every service and check coherence about the state of the entire system in an environment. And we need to make sure that we are testing these against like the real services running in a namespace. So we automated all that stuff in the pipeline.
Yeah, so the setup we ended up is kind of like, it's a little bit similar to the preview environments thing we were talking about earlier, but we kind of extended it by saying, well, we want to take whole scenarios and be able to deploy them in a pull request and just create a namespace and destroy the namespace again. Yes.
Face some challenges. Yes, it was quite interesting. Yeah.
Yeah, I guess we're a little bit short on time, so perhaps we go through this fairly quickly.
Yes.
Yeah, so it's fairly resource hungry, like what we're doing, because we've got,
Yes, thank you.
Yeah, we've got quite a lot of pipelines running, lots of jobs, lots of Helm charts, all our deployments, running all testing tests. Yeah, it's the market.
Yeah, it is, yes.
Also, the number of pull requests we generate, like that's you start to see things like little glitches in GitHub. Like it might fail like 1 in 100, 1 in 1,000 times, but when you run thousands of jobs, then you start seeing them.
Yeah. So it got quite interesting. Now it's more stable, right?
Yeah. So we found we had to build a lot of retries into the pipelines. Basically, we had to wrap a lot of commands in retries, so we can support that. Yeah, also another thing, GitHub does very good things. Yeah, which we don't normally hit that, but there are particular ways of using update bot that you can easily, if you like you have it to easily hold GitHub. You can also end up hitting this with the jet to like built-in Jenkins mechanisms for like public resources. We've got lots of them. Yeah, there's also when you've got lots of microservices doing different but similar things, then you can easily end up with duplication, particularly on helm charts. But I realize not everyone can do
Definitely not that much.
yeah, so this is less of a challenge and more of a like positive actually. That the Jenkins-X whole community is moving really fast. Like they're doing like really interesting stuff during the whole kind of serverless model. I mean, it's already Kubernetes native, but they're kind of taking it to the next step now. It's becoming a challenge now to keep up with these guys.
It's very hard to keep up with the Kubernetes community in general. Everything is changing every day, but at the same time, that's positive because we clearly see some refinements being made, which makes us closer to what we are basically aiming. And in this case, it's very good to see an open source project that is doing continuous delivery, so you can go every day, and if you find an issue, you just submit the pull request, they will test it and release it. So in matters of hours, you will get your environment that is running Jenkins-X, and you will be able to update that and get that fixed. For us, that was key because we found issues and we said, okay, without issue, we are blocked because we cannot run our pipelines. We fixed the issue, 2 hours later, we upgraded our platform, the issue was fixed. That for me is kind of amazing, and being an open source project as well, we are aiming to do that as well, and it's getting closer and closer.
That's
another thing, another very important thing. It was announced on Monday, right? I don't know how many of you guys saw this, like the Continuous Delivery Foundation, sponsored by Google and some other companies, and Jenkins-X is there, Tekton is there, Spinnaker is there. And it's very good to see this kind of standardization happening in the industry because all these best practices are going to be promoted and we should be able to just use them instead of keep thinking about this practice.
And that's us.
Please feel free to reach out. We are open and we are more than happy to share. Yes?
You did, sorry for rushing in.
No worries.
Just have one quick question if anyone has one. Well, you should say one quick question, someone comes up with the most convoluted question. No, I think you've got away with it. So yeah, once again, thank you, Mauricio, thank you, Ryan, and thank you. Okay.